Hi, welcome to Viva Lambda. This is Kem speaking. This video is a part of a series about built-in functions and statements in Python. Feel free to check out other topics in this series if you're interested in learning or remembering Python. Today we are going to briefly cover a topic that is a source of confusion for beginners and intermediate developers and the like. Today we shall see the AND operator in Python, both logical and bitwise. In most use cases, you would want to use a logical AND operator. So much so that I can't think of an example where I would use a bitwise AND operator right now. Please do mention a popular use case for bitwise AND operator if you think of one in comments below. The logical AND operator is used for combining conditions. Either side has a false value, it would evaluate your expression as false. Now, this is not the case for bitwise AND operator. Bitwise AND operator compares two values bit by bit, meaning that it looks at the bit representation of the value in question, iterates over the positions of that representation. During the iteration, it checks if the representation for the position is equal to 1 for each value. If this is the case, it returns 1. If not, 0 for that position. Let's look at our example. We have two variables, a and b, which are integers. C is the result of their logical AND expression, and E is the result of their bitwise AND expression. Weirdly enough, the value of C is 23, and not something like true, for example. We might conjecture that when both sides of the expression is non-zero, the logical AND simply outputs the bigger value, though the definition of bigger should be defined for non-integer values. Well, to be completely honest with you, I don't know why logical AND does not output a Boolean value. I'm quite uneasy with this. However, let's look at our sixth line where we observe the value of bitwise AND, which is 16. It does not seem like it has any relation with the values of the variables we had used for the expression above. Let's see the bit representation of these integers. Here in the next cell, we can see that decimals quite clearly do not correspond to each other. Thus, the resulting value is 1 for the first decimal. Here, 1 for the first decimal, and 0 for all the rest. Here in the next cell, I define a function to represent what's happening when we are using a bitwise AND. The function is not the optimum solution, of course, but it should give an idea about what's happening. The main difference with this function and the bitwise AND operator is that bitwise AND operator in Python works also for different sized bits, integers with different bit lengths. Again, I have no idea why or how it works for different sized integers. I searched the source code of Python in GitHub, but I couldn't find the section where the bitwise AND is defined. It is declared in the abstract abstract point h, abstract header, basically, and is referred in several other files, but I could not find its definition. If you could find the link to its implementation, or if you know why or how the bitwise AND operator is implemented for integers with different bit lengths, please do provide your opinion in comments. As you can see, our function reproduces the behavior of the bitwise AND for integers who have the same bit length. Let's see that right away. So I'm running cells here. I define my function, and we obtain again 16 as a result of our function. One thing I do is to simply multiply the bits to obtain the resulting bit. Here you can see the multiplication being done. Why? Because multiplication captures the behavior of the Boolean AND for integers quite well. Think about it. 1 times 1 is 1, 0 times 1 is 0, 0 times 0 is 0, and etc. etc. So, this is it about logical and bitwise AND operators in Python. I hope you find the information useful, and thanks for watching.